All right, so this is easy axis, and we're going to try to do this in 10, 1, 0, F. Okay, here we are. Good start. So this assumes that you have some basic knowledge of what's happening in the heart with the pacemakers. If you don't, you need to review that before we get here. Anyways, right here on this left side, what we see is a big triangle. This is what we call Einthoven's triangle, and there's two pieces of this that I want you to look at. And I want you to look at AVF and 1. These are your key leads for quickly understanding what's going on with the axis. Now we have to keep in mind throughout this entire thing that impulses that travel toward a positive deflection or toward your electrode appear as positive deflections. Right? They travel in this direction toward that positive electrode from the heart. It shows up like this on your EKG, and that's what we call a positive deflection. Now, there's two leads we're going to talk about again. We have lead 1 and we have lead AVF. Lead 1 essentially looks at the heart from your left arm in this angle. So your heart's kind of here and it's looking straight across the middle of it. So we're getting the impulse in this plane. Lead AVF is your AV foot lead. And what that does, it looks at your heart basically from the top down. It looks at it from this angle looking up. So impulses that travel from the top down will appear as positive deflections on your EKG. What does this mean with X deviation, and what the hell is this dude talking about? Fear not. So right here is a great diagram. It's worth memorizing a lot of these numbers on here. The numbers that you should memorize are the -30 to the +90. These are positive ranges. These are your normal axis ranges. The 180 kind of makes sense because we're going from 0 to 180, positive, negative, and this side's your negative. I think there's some mathematical correlation there too, but I don't math, so we're going to just erase everything here, and we're going to talk about the thing I do know about, which is axis. Now, when you're looking at this, you can imagine, keep in mind anatomical location, and your heart is right smack dab in the middle, but your heart's red, so we're gonna color it in red. Now, when you have an impulse that goes in your heart, keep in mind you're going to start over here in the anatomical top right with your SA node. And then it travels from the SA node to the AV node, through the bundle of His, through the bundle branches, and up through the Purkinje fibers. In each one of these paths that this impulse takes adds a vector to the mix. So you have a vector going this way, you have a vector going that way, and then you have a vector going that way, and you have a vector going that way. And if you add together all the vectors like you did in math class forever ago, you're going to find out that a normal axis for a heart is, bam, right there where it's labeled, between +90 and -30. And that kind of makes sense. That's kind of what we expect. Now, if we're looking at lead 1, we're going to start with lead 1. We're going to focus on lead 1. We're going to beat lead 1 to death. Keep in mind that anything you see at lead 1, this is your positive electrode over here. And any impulse that comes toward lead 1, any part of the heart, any part of that electrical activity that travels toward lead 1 is going to appear as a positive deflection on your EKG. Now, if that same impulse, let's say that impulse, instead of traveling toward, let's say it travels away from lead 1, that's going to appear as a negative. That's going to have a negative impulse on your EKG, but just in lead 1, just in lead 1. We're only talking about lead 1 right now. And keep in mind the angle we're looking at the heart from. Kind of looking at this side over here. We're looking at the left side of the heart, and we're looking at impulses traveling toward us. Get it? Because there's a camera? Yeah, whatever. On the other token, we have AVF. AVF is your augmented V foot lead. And you're looking at the heart from the bottom up perspective. And any impulses that travel toward AVF are going to appear as a positive deflection on your EKG. Now, an impulse that travels away from AVF is going to appear as a negative deflection on your EKG. Following? Yeah, good. You're smart. You got it. So what does this mean? Well, this means that we can use the impulses in just these two leads to determine exactly where in the heart the impulses are going. It's not definitive more than telling us the general addition of all the vectors in the heart, but that's the basis of axis deviation. I don't think it's super duper important in most cases, but they want you to know about it, so we're going to teach it. So let's start with the basics. But Jeremy, we already got the basics. Well, we're going to get basicer, all right? We're just going to start talking about lead 1. All right, and we're going to talk about normal axis. So here's your heart, real happy, real anatomically correct, and we have a normal impulse that travels from the top left down to the bottom right. We're talking about normal axis. Now let's think about where this vector is actually going. Is this vector traveling toward lead 1 or away from lead 1? Hey, look, you can see things. It's positive. It's traveling toward lead 1. It's traveling in this direction. It would be traveling toward lead 1 anywhere in this half of the circle, right? So anything in this half of the circle will appear as a positive deflection in lead 1. So that tells us, we're talking about normal axis right now, that if we have a normal axis, lead 1 is going to be positive. Now what's happening in AVF? AVF, we're still traveling in this direction, but anywhere basically in this half of the circle, right there, this guy, what the, see that? Cool. Anywhere in this half of the circle is going to appear as a positive deflection in AVF. So if you have a normal axis deviation, I know you can probably see what's going on really well in this whole thing. If you have a normal going this direction right here, this is the axis, this is a normal axis, this is a normal impulse from the heart, traveling in this direction. Is it going away or toward AVF? Yeah, that's 2 in a row. It's going toward AVF. So that means we're going to also have another positive deflection in AVF. So there we go. There's our first piece of the puzzle. Normal axis deviation, positive 1, positive AVF. Now let's talk about left axis deviation. Now let's say that instead of going directly where it's supposed to, there's something going on at the heart, like a cardiomyopathy or left ventricular hypertrophy. There's some reason that that side of the heart is way bigger and there's more impulse traveling over here somewhere. Whatever's actually happening, the net vector, the impulse, is traveling in this direction, right? So again, let's think about what's going on with our 2 halves of this circle. Let's start with lead 1. Is this deflection right here, is it traveling toward lead 1 or away from lead 1? Yeah, it's traveling toward lead 1. Bam, so it's a positive deflection in lead 1 for a left axis deviation. I'll just jot that down right there. Now let's look at the other one. We have AVF, we're looking it up from the foot. We're looking at the impulses traveling this way, and we have to make the decision, is the impulse that we're seeing, we know right now it's going to left axis deviation, we have that as a gimme, but is this impulse that's going into the left axis, is it traveling toward AVF or is it traveling away from AVF? What's that, 4 in a row now? Yeah, it's traveling away from AVF, but that one's negative. So we see that as a negative deflection in our EKG. Again, it's negative because this impulse is traveling away from the positive lead. So impulses that travel toward this lead come out positive, impulses that travel away come as negative. Keep remembering that, keep saying that, don't forget it. Left axis deviation, in this case, it's traveling away from AVF, so it appears as a negative. Now right axis deviation, where are we at for time? Probably too slow, but that's okay, we'll make it work. So what's this? Oh, I don't know what that does. That's a new button. Anyways, so let's talk about our right axis deviation. So for whatever reason, maybe a right-sided heart enlargement or some weird aberrant pathway going on in the heart, instead of traveling in this direction, the net vector of all of the electrical impulses in the heart is traveling in this direction, from anatomical left, top left of the heart to anatomical bottom right of the heart. And so we have it going in this direction. Let's start with lead 1. Is this vector traveling toward or away from lead 1? It's traveling away from, so that means it's negative. So lead 1, RAD, negative. Now let's think about what's going on with lead AVF. Is this vector, the net vector of all the electrical activity in a heart, is it traveling toward AVF or away from AVF? It's traveling toward AVF. And because it's traveling toward AVF, it's a positive deflection. Now let's talk about the most extreme, badass of the vectors we can be seeing today. For some reason, something has gone terribly, terribly wrong in the heart. And now we have a net vector traveling from here, and it's up here in no man's land. Usually, keep in mind that the regular vector of the heart goes from like this direction down. This is totally opposite. This is a problem. if someone has an extreme right axis deviation, either you screwed up in figuring out what's going on, or that patient is an alien. Anyways, no, it can actually happen. There's a lot of reasons. So anyways, what we're seeing here is that right here, look at that vector. We have our two circles here. Let's start with lead 1. Is this vector right here in our extreme far right axis deviation, is it traveling toward or away from lead 1? It's traveling away from, so that's negative. Lead 1, negative. Same idea, AVF. Is this impulse traveling toward or away from AVF? Hey, it's traveling away from. I'm really mad I didn't get that job for Dora the Explorer, talking to, oh, you see the map? Anyways, so that's the basis of it. Take a quick snapshot of this. Figure out what's going on. Think about what's happening. Great. Moving on. We're just going to put some stuff here. We'll go positive, positive, negative, negative, positive here, positive there, negative there, whatever. No duplicates, right? Perfect. Now, all we're going to be doing here is looking at these two things, this graph, and trying to figure out, based on these plus and minus signs, is what direction the axis is going in. Start with purple. Now, what I like to do on tests and stuff to really understand what's going on is draw out my little bullseye. All right? I know lead 1's over here. I know AVF's down here. I have that memorized. So we're going to start with lead 1. I see a positive deflection, so I know it's traveling toward that. And negative, I know it's traveling away from AVF. Get why I did that? Positive traveling toward lead 1, right there, and then negative traveling away from AVF. Check it out. We're over in this section right here because we add those two vectors together, and generally speaking, we can call this left axis deviation. Not too shabby. Let's go to the next one. Lead 1 is a negative, so it's traveling away from lead 1. Positive, AVF, so it's traveling toward AVF. I know it's over here in this little area. And I know that area correlates to the right axis deviation. And I see a couple positives. So I know this first positive, lead 1, is traveling toward lead 1. I want a different color. Hold on. It's traveling toward lead 1. And the other one here, an AVF, this guy, is traveling toward AVF. So I know it's somewhere in this. This is our normal area, or within normal limits. That's our normal axis. That's what we can expect. And finally, we have negative and negative. And I know, we're going to figure it out. It's probably going to be over here somewhere, but we'll just go through it. So negative, is it traveling lead 1? It's traveling first and foremost. It's traveling away from lead 1. Then it's also traveling away from AVF because they're both negative. If they're positive, they travel toward those leads, but they're not. They're traveling away. And because I add those two vectors together, it's probably going to end up somewhere over here. And so this is it. We can label this as extreme. You're not paying for this. You get what you get. All right, let's wrap it up. Let's finish it up. Let's go full circle here and understand what the hell we're talking about. So here's a great EKG. All right, we're going to look at two leads on here. Which two leads are we going to look at? Yeah, you got it. 1, AVF. I'm going to draw our little thing here to make our lives easy. 1, AVF. Let's look at lead 1. Now what we want to actually look at here is we're seeing, this is the isoelectric line right here. Ooh, I broke it. Yeah. This is our stop breaking. What the fuck? Right there. That's our isoelectric line. What we want to do is figure out, is more of the deflection from that isoelectric line going up, positive, or is it going down, negative? Now you have more than 3 brain cells, so you can see that, hey, check it out. This is going mostly up. QRS going up. There's a little bit going down here, but most of it's going up. So what we're going to say is lead 1 is overwhelmingly positive. And so we're going to just add that to our little graph here. Positive. Now let's look at our other one, AVF. Where is it? There's the AVF. I circled it and everything. So we're going to be looking right here. Let's look at that guy. And let's figure out, do we have more of this going up or more of this going down? We're looking mostly at this QRS complex. This is the most important part of what we're looking at. But you'll notice that there's a lot of up, a lot of down. Yeah, someone more scholarly might be like, oh, we're going to count the boxes and go through and figure it out, get an exact measurement. I'm not that person. What I'm going to do, I'm going to look at this and say, hey, that's a biphasic QRS. What's that mean? That means it goes up and it goes down. Biphasic, two phases. But how do we draw that? There's no biphasic anywhere on this chart. That doesn't make any sense. Where's the chart? It doesn't matter. There is no chart. But this is AVF. So if we had a positive AVF, it was going all up, it would be traveling in this direction. If we had a negative AVF, it would be traveling in this direction. But we don't. We're somewhere in the middle. We're calling it equal up, equal down. So there's nothing. We get a dot, non-contributory dot. Doesn't make a difference, ruins the whole thing. Thanks a lot, dot. What's actually happening here is all we have now is this right here. And because you were diligent enough to remember exactly the numbers and the degrees on this chart, you remember that's 0, you remember that's negative 90, and you remember that's either positive, or negative 180, and then this is positive 90. What we have here is a net vector, 1 in AVF, is somewhere around 0, it's traveling in this direction. But you also remember that a normal axis is between negative 30 and positive 90. So we're going to call this a net vector of 0 because we just have that lead 1 to bring us over here and no up, no down from lead AVF. We're going to call it approximately 0. Wow, that seems like a lot of work. You're right. Don't do it next time. When you're in practice, just look at that number. It's close enough. You get P, QRS, T. Your P is your net vector of all the P waves and what axis they go on. Your T is the net vector of all the T waves and what axis they go on. And right here in the middle is your net vector of your QRSs and what axis they're on. That's the number you care about. That's the number you write down. Also, this person's having an MI, and they have an axis deviation of 2 degrees. The end.